Hello everyone, welcome to this course on Exadata Cloud Service Overview. My name is Bal Sharma. I am part of Oracle Cloud Infrastructure Product Management team. Before we get into this course, this is our safe harbor statement. I will take a pause here so that you can read this. In this course, we are going to discuss Exadata Cloud Service on Oracle Cloud Infrastructure. I assume you should have gone through our foundation level course on Oracle Cloud Infrastructure for a better understanding of several concepts which are applicable to Exadata Cloud Service, which I am going to discuss further in this session. At the end of this training, you should have a fair idea on what is Exadata Cloud Service on OCI. You should be able to explain various components of Exadata engineered system. I am going to briefly cover Exadata basics as well. I will spend some time to explain for those who are new to Exadata system. We will learn how Exadata Cloud Service is architected on OCI. We will also look at a typical Exadata Cloud Service deployment architecture diagram, followed with how to provision them on OCI. Some of the best practices for deployment and consolidation as well. And at the end, I will take you through a demo where I will briefly show you Exadata Cloud Service environment provisioning steps and will log in to a Exadata Cloud Service system to show you few basic stuff. So let's start. We provide Exadata Cloud Service on Oracle Cloud Infrastructure platform across several OCI regions. As you might already know, OCI is hosted in regions and availability domains. Regions is basically geographical areas, and availability domains is one or more data center located within regions. It comes in different shape, quarter rack, half rack and full rack configurations, and users have an option to pick the desired shape during provisioning based on their subscription. Online dynamic scaling of OCPU resources is available in every Exadata Cloud Service shape so that customers can pay only for the OCPUs that they use. That way, they would be able to reduce the cost compared to a traditionally purchased platforms. Exadata rack consists of database nodes known as compute node, storage nodes, and networking components like InfiniBand connectivity, switches, etc. They also provide RDMA-based storage access to the compute nodes, where RDMA stands for Remote Direct Memory Access. Exadata storage software runs on storage servers and they have ability to offload database SQL processing on a storage tier. Currently, a single virtual machine per compute node is supported. It allows root access for customers while protecting hardware and network. Database nodes are virtualized using gen-based OVM. Oracle manages a storage cell, switch, management, or IB networks, while customer manages the database compute nodes. Exadata Cloud Service provides a control plane, a web-based self-service management interface for Exadata provisioning and interactive access to service administration function. REST APIs are also provided for service administration function. Applications would be able to connect to Exadata Cloud Service database using any standard JDBC SQL StarNet based connections from OCI or on-prem or any other cloud-based deployments. You can establish a secure shell SSH connections for accessing Exadata Cloud Service compute nodes. ExaCS uses network interfaces and subnet exclusively for database backup to an Oracle Storage Cloud Service buckets, separate from the client subnet which is used for database connections. Customer-facing APIs for Exadata management are integrated with OCI Identity Management Console, and customers can control the API access via standard identity authorization policies. So customers have complete access to all Oracle databases and OS features to ensure a smooth and simple migration from on-prem Oracle deployments to Exadata Cloud Service. Each Exadata Cloud Service instance is a virtual machine. They are known as DOMU, which is owned by customer. In each database server of the Exadata system, customers have root privilege for Exadata database. Customers perform familiar database administration and OS administration tasks added by cloud automation for their backups, patching, and upgrades. So all supporting infrastructure for Exadata service is deployed, maintained, and managed by Oracle, including data center networking, private Exadata InfiniBand networks, physical Exadata compute and storage servers, firmware, and Exadata system software. So this allows customers to focus on their business needs and application requirements and not on database infrastructure monitoring and management. Exadata Cloud Service runs Enterprise Edition, Extreme Performance version, which has all of the database options and Enterprise Manager packs. Database instances are configured with huge pages memory management. Customer can also customize syslog format for log analytics and better integration with any SIEM products. It allows users to have a read-only access to a storage cell via ExaCLI API, and block storage volumes cannot be attached to Exadata compute nodes currently. With Exadata Cloud Service, you can either store your backups locally or in OCI object storage. Now we'll talk about Exadata Cloud Service Networking. Exadata Cloud Service provides secure high-performance access from both on-prem systems and from other Oracle Cloud Infrastructure services. To ensure consistent high performance and isolation, multiple separate physical networks are provided on each Exadata systems. The data and backup networks provide 25 GB per second connectivity for high bandwidth use cases such as application connectivity, backups, data loading, and disaster protection using DataGuard. InfiniBand is used internally for ultra high speed compute and compute to storage networking. In addition, there is a secure, separate, and isolated cloud management network known as admin as well as ILOM ports, and they are used by Exadata Cloud Operations to manage the servers, storage, and switches. Exadata and OCI platform are integrated with VCN, which is software defined network, and the customer visual database nodes are presented via regular virtual NICs. We call it vNICs in customers VCN. Customers basically create a subnet in a VCN via either regular VCN APIs or console, and customer call the Exadata service API to allocate an Exadata quarter rack or half rack or full rack and passes it to the subnet. 4 vNICs will be allocated on each subnet, 2 for database client network and 2 for database backup traffic. Multiple private IP addresses will be allocated for each vNICs, which is required by database rack software, for example, scan host and floating IP addresses. DB client in the VCN can access to the Exadata database node via private addresses. Customer can use all the standard VCN features including security list and routing tables to control network access to their database nodes. Additionally, VPN and Fast Connect can be used to connect to Exadata Cloud Service. Service Gateway provides connectivity to OCI object storage and other services within OCI regions, which eliminate a need for NAT Gateway or Internet Gateway. Now we'll try to look at ExaCS architecture on OCI. Each Exadata database server contains at least one virtual machine known as DOM-U. They are running on a VM hypervisor known as DOM0, and this configuration ensures a distinct separation between the Oracle managed and customer managed components. Oracle manages the hardware, firmware, and DOM0 by using integrated Layout Manager, ILOM, and DOM0 management network interfaces. Customers have no access to these interfaces. Minimal resources are allocated to DOM0, only 2 CPU cores and 16 GB of RAM on each of the physical hosts. Each DOM-U is provisioned with a complete Oracle database installation. that includes all the features of Oracle Database Enterprise Edition, plus all the Database Enterprise Management Packs and all the Enterprise Edition options like database in-memory, real application clusters, etc. Customer has secure access to each DOM using the client and backup networks. The client and backup networks use bonded network interface to maximize the performance and availability. Operating system security for DOM is based on an SSH public-private key pair. Customer register a public key in each DOM. After that, the corresponding private keys must be provided in order to connect to a DOM using SSH. At all the times, customer retains the private key that enable access to the DOM operating system. As a result of this configuration, customers manage each DOM and all of the Oracle software that it contains. Oracle provides assistance through the provision of cloud tools that simplify backups and patching operations, but ultimately it is the responsibility of customer to perform these operations. Now we will take a look at what Exadata Cloud Service X7 provides in terms of hardware infrastructure. In this example, we are looking at three different configurations: X7 quarter rack, X7 half rack, and X7 full racks. There are X6 version of Exadata Cloud Service is also available in Oracle Cloud Infrastructure. So for simplicity, we are going with the latest, which is X7, and we'll discuss what a customer is going to get when they provision these cloud services. So in terms of number of database compute nodes, X7 quarter rack has 2, half rack will have 4 compute nodes, and full rack is going to have 8 of them. So maximum number of OCPUs supported by a quarter rack is 92, a half rack supports 184 OCPUs, and full rack supports 368. Total memory on a quarter rack configuration is roughly 1.5 terabyte. On a half rack it goes roughly 3 terabyte, and on a full rack it's roughly 5.5 terabyte. In terms of flash capacity, which is NVMe flash, quarter rack has 76.8 terabyte of flash. Half rack goes 153 and full rack provides 307 terabyte. Another important aspect to know here is you need to always consider the maximum database size. So in case if we don't take a local backup, the maximum database size on a quarter rack could be 85.5 terabyte. On a half rack configuration it can go 171 terabyte, and on a full rack we can have a 342 terabyte of one single database. In terms of network connectivity, quarter rack or half rack and full rack, they all have bonded 25 GB Ethernet attached to it. Another note here is ExaCS X7 also includes 8 drives, which is 600 GB in size, for local drives attached to the server. Approximately 1.1 terabyte of local capacity is available for Oracle homes per database server, and it supports minimum number of OCPUs equals to 0. This is very important point. If you make the OCPUs to 0, it will shut down the VMs and you won't be charged for the database OCPUs. So you need to plan the shape of Exadata Cloud Service based on sizing. You can scale up and down within shape. Currently, we are not supporting scaling across different shapes. For example, upgrading from a 1/4 rack to half rack is going to be a kind of redeployment. We'll talk about Exadata Cloud Service, customer versus Oracle managed in terms of responsibilities. So customers have complete access to all Oracle database and OS features. All the patches are pre-staged. For example, operating system, grid infrastructure, and databases. You can patch what you want when you want on your schedule. Patching are automated through cloud tooling. REST services makes scheduling easy. And as we discussed, Oracle manages all the underlying infrastructure, means proactive hardware fault notification, or Oracle patches the following rolling patches on DOM0 servers, storage hardware and software, the networking component, firmware, and hypervisor. They all are Oracle's responsibility to maintain. Now let's talk about a typical Exadata Cloud Service deployment architecture. In the diagram, I'm assuming a customer wants to use Exadata Cloud Service along with certain application workload. To start with the architecture, you see you are going to deploy the resources in a region of Oracle Cloud Infrastructure. So VCN is the first starting point, which is Virtual Cloud Network, and VCN creation needs a CIDR block to get started. In this case, I have taken a CIDR block of 10.0.0/16, and I have taken a CIDR block which provides a large network for all the resources. So depending on the need, you can change the same. For example, if you take a CIDR block of /19, 10.0.0/19 VCN, it can go all the way up to 10.0.64.0/19. Or if you select a /24 CIDR, it can also go from 10.0.0/24 to 10.0.2.0. So important aspect here is the first 2 bits are network bits and the last 2 bits are host bits. That can change. So network bits will be fixed and host bits can be changed. So you have several calculators which can provide you how many subnets you want, and depending on your needs, you are going to choose the required CIDR. For example, /24 can provide a maximum capacity of 32 networks with 254 hosts each. Or /23 will provide you 16 network with 510 hosts each. It is a decision you will take keeping in mind there should not be a overlapping CIDR with your on-prem networks or other VCN across the region. So as a best practice, I have also kept a Bastion host here, and this will allow you to connect to internal private subnet resources securely over internet. In a production kind of deployment, you will generally have either IPsec VPN or a fast connect kind of connectivity from your data center to Oracle Cloud Infrastructure, and the connections goes through DRG, which is Dynamic Routing Gateway. If you notice here, I have private subnets which are created for my applications as well as for databases. These private subnets can be used for deploying several VMs, and they can talk to the Exadata database system securely, which is also hosted on a private network. So you will have one or more private routing tables. They are for routing traffic for egress and ingress. Depending on the need, you can have additional gateways. In this case, I am showing you that a service gateway can talk to all of the IAD services in Oracle Service Network. It can talk to the object storage for backup needs. It can talk to storage services for patching needs. The NAT gateway here is an optional. It is only needed if you have a use case for it. One of the example could be you want to upload certain diagnostic logs to Oracle support in case you have opened up a service request and want to directly upload it from your compute nodes on Exadata Cloud System. So in that cases, it could be desirable to have a NAT gateway, but it's completely a design consideration. The NAT gateway is not a prerequisite anymore for deploying a Oracle Exadata Cloud Service. So Service Gateway can handle pretty much all the functionality. Oracle Cloud Infrastructure is also integrated with other services like identity and access management, auditing, object storage kind of services. So with this, I will move to the next topic, which will talk more about Exadata basics. Let's talk about the technical foundation for Exadata Cloud Service. In this machine, we have database nodes, which runs any database starting with 11G through 18C, and it has real application clusters. Clusters and database run on servers. We call it database node or compute nodes. A full rack configuration can have 8 nodes running Oracle Linux. In addition to this, we have storage cells, and here disks are not attached to the database compute nodes as we do in a normal traditional case using direct attached storage. But all the disks are part of a different server. They are known as a storage cell, and there are 14 storage servers in a full rack configuration. Oracle Exadata server software runs in those storage cells on top of the operating system. In addition, we have flash disk, and each storage cell have 6.4 terabyte of flash disk. We have InfiniBand circuitry, and that is for connectivity of cell and the nodes, and they provide very low latency between compute node and a storage cell. So there are 3 InfiniBand switches for redundancy and throughput. There is no fiber component here between compute node and storage. There are Ethernet switches, which is used for communication. Then when it comes to the software capabilities, there are a vast variety of softwares innovation applicable to Exadata Cloud Service. It has a storage indexes which avoids unnecessary I/O operation by replacing them with a few in-memory lookups. Exadata Cloud Service has ExaFusion, which is direct-to-wire protocol, and it allows database processes to read and send Oracle rack messages directly over the InfiniBand network, which improves the OLTP response time and scalability in Exadata system. It has a smart fusion block transfer that improves OLTP performance further by eliminating the impact of redo log write latency when moving blocks between the nodes. Another term is a smart flash logging, and they accelerate the OLTP by using flash memory in Exadata storage combined with high-speed RAM memory in Exadata disk controllers to reduce the average latency of database commits. We'll see hybrid columnar compression. They utilize a combination of row and columnar methods to greatly compress the data, and it enables tremendous cost saving and performance improvements due to reduced storage capacity and reduced IOs, especially for analytic workloads. So in-memory columnar formats in flash cache extend the Exadata columnar flash cache by automatically transforming data into in-memory columnar format, and it is loaded into flash cache. Smart scans can leverage ultra-fast single instruction multiple data, means SIMD vector instructions, thus processing multiple columns values with a single instruction. A smart scan provide with predicate filtering, which is only the requested rows are returned, and column filtering, which means only the requested columns are returned. Another important concept is IORM, and it is an integral software component of Oracle Exadata storage server, and it runs within the cell services on each of the cell. Each cell disk maintains an IO queue for each consumer group and for each databases. Exadata Storage Server IO Resource Manager allows us to govern IO resource usage among different categories, which could be applications, databases, or within databases it could be inter-database or intra-databases, and based on workload types. So let's spend some time on licenses covered for database and database options. Exadata Cloud Service is available through 2 flexible subscription offering, license included, as well as bring your own license model. So license included subscription model includes all the features of Database Enterprise Edition plus all of the Oracle Database Enterprise Manager packs and all options such as Oracle Tip Data Guard, automatic storage management, partitioning, advanced compression, security, database vault, real application testing, OLAP options, spatial and graphs. So Exadata Cloud Service includes multi-tenant options as well, which includes high consolidation density, rapid provisioning and cloning, efficient patching and upgrades, and they simplify the database management. The subscription model is ideal for customers without existing Oracle database license or customers seeking to use database features beyond what they currently have licenses for. So let's move to the next slide, and we'll try to look at operating system which is available on Oracle Exadata Cloud Service. So it's Oracle Linux 7. While the image looks like just a Linux image, it is in fact a highly optimized and integrated database platform. It contains optimized set of operating system packages, Exadata specific packages, configurations, and firmware and more, which are directly usable for the customers to run the Oracle database in the best possible way. There are several changes which Oracle Linux 7 brings. All the new environments provisioned have 19C compatibility, and it is powered by Oracle Linux 7. This supports images for different purposes, for sales, for bare metal, DOM0, DOM-U DB nodes. It supports multiple ways to image and update the hardware. It supports full rolling upgrades. You can adopt to latest features which are available in the kernel. Few things which have changed here in Linux 7. One is systemd, which has replaced the older init scripts, and it is designed to overcome the shortcoming of init. It itself is a background process which is designed to start processes in parallel. That way it can reduce the boot time and computational overhead. It has a lot other features compared to init. The another change is Chrony, and it's a different implementation of the network time protocol. So it is able to synchronize the system clock faster and with better accuracy. Another good reason to use Oracle Linux 7, it provides hardened security. It enables advanced intrusion detection environment known as AIDE. AIDE helps to track down which file has been affected in case the system is compromised. It runs a daily cron job that monitors the system for changes to the file in specific directories. AIDE automatically raises critical software alerts. We see that the compliance have been also greatly enhanced starting with 19.1 release with SDIG notable changes like password quality and SSH client alive interval. So in terms of password quality, it is enforced for new passwords, and when it comes to existing systems, they can be upgraded with no need to change password, and new restrictions will be in place only when someone tries to change the password. System that uses SSH equivalence, they will not see any impact from these changes. The another parameter, SSH client alive interval, parameter is known as client alive interval. You can set a value to it, and normally quiet SSH sessions will time out faster, and you can prevent it with this new feature. So if you want to send keep alive on your long SSH sessions that are quiet, you can use client alive interval. Now talk about the Exadata software architecture. There are three main Exadata storage cell processes which are provided by Exadata Storage Service. The first one is cell SRV, known as cell services. The cell SRV is the primary component of Exadata software running in the cell, and it provides the majority of Exadata storage service. It services the database request for disk I/O and advanced Exadata cell services. It is implemented as a multi-threaded process, and it uses the largest portion of CPU or processor cycles on a storage cell. It provides advanced SQL offloading capabilities and serves Oracle blocks when SQL offload processing is not possible. CEL-SRV also implements the I/O resource management, that is for metering I/O bandwidth to various database and consumer groups which are issuing I/Os. The second service is MS, that is Management Server. Management Server implements a web service for cell management commands and runs background monitoring threads. MS processes the primary interface to administer, manage, and query the status of Exadata cell. It works in cooperation with Exadata cell command line interface. They are known as ExaCLI or cell CLI, and they process most of the commands using these command line interfaces. The third one is RS service. The RS service is known as Restart Server, and it ensures the ongoing functioning of Exadata software and services. It monitors the heartbeat from the management service and the CEL-SRV processes. If the processes fail to respond within allowable heartbeat period, the service are restarted and a notification are sent to the user. Cell CLI or ExaCLI allows user interaction and configuration management service, which displays the management creation and deletion of grid disk or changes in hardware, SNMP traps, alert. Cells can be added to cell IP.ORA dynamically. So let's take a look at the right hand side. It talks about how to establish the connection between I/O or ASM layer of ASM database to Exadata system. So leaf cell, which are linked with DB and ASM, they talk to CEL-SRV process. IDP protocol, which we already discussed earlier. There are multiple threads in CEL-SRV. All threads perform asynchronous I/O to disk and network. There are multiple things like a smart scan, which is enabled in RDBMS and CEL-SRV. CellInit.ORA decides which network takes storage traffic. Now we'll try to understand function of diskmon. It is a critical component of Exadata I/O fencing mechanism. There are master diskmon. The process name is diskmon, which starts with CSS and communicate with CEL-SRV. There are slave diskmons known as DSKM, which is part of every instance and communicate with the master diskmon. Diskmon process handles cell failures, I/O fencing, I/O resource management, plan propagation, such as broadcast intra-database IORM plans from RDBMS to the cells. And it can also broadcast other control information from RDBMS and ASM instance to the cells. So let's talk about a high-level design of flash cache. It includes Exadata Smart Flash Cache, which provides the capability to stage active database objects in flash. The second is Exadata Smart Flash Logging, which speeds the critical function of database logging. There is a third type, which is columnar cache. It uses the same flash device area as flash cache. So there is no hard space partitioning between flash and block cache and columnar cache. Space is allocated based on LRU strategy. Columnar cache is essential for data warehouse kind of workload, and if OLTP requires little or no space, columnar cache can use most of the remaining flash space. Same disk region can be cached both in columnar cache for data warehouse and flash cache for OLTP. Let's move to the next topic. In this slide, we will try to understand what is the disk layout as well as physical layout on Exadata system. So there are two kinds of disks. Each storage cell has 12 physical disks. In a high capacity configuration, they are 10 terabyte in size. So apart from these, there are physical disks which are attached to compute nodes, and each compute node in Exadata configuration has 4 600 GB. They are hot swappable and they are expandable up to 8. Physical disks are divided into multiple partitions, and these partitions are presented as a LUN to the cell. Some LUNs from compute node disk are used to create a file system for the operating system. When it comes to a storage cell, we create cell disk from the storage cell disk, and cell disks are further divided as grid disk and grid disks are used to build ASM disk groups. An ASM disk group is made up of several ASM disks from multiple storage cells. So finally, when we create a database, they are built on these disk groups which are created out of a storage cell. Now we'll get into Exadata Cloud Service Provisioning. We have already discussed this typical deployment architecture, and this diagram we have Exadata system as well as Bastion host, and all of the applications as well as database is hosted in private subnet. We will go into more detail about each of the constructs. When we'll get into demo, we will try to understand the deployment flow. So let's take a look at Exadata Cloud Service deployment flow. First, we start with creating a VCN, which is Virtual Cloud Network. Then we create a gateway, and this gateway could be NAT Gateway, it could be Internet Gateway, or it could be Service Gateway. One thing to note here is Service Gateway can handle all of the internal communication, including backups, patching within OCI regions. So not necessarily you have to create a NAT gateway or internet gateway for deploying Exadata Cloud Service. There could be need when you want your Exadata nodes to talk outside, and then in those situations you can create a NAT gateway which will provide you internet access over private subnet. We will create routing tables, we will create security lists, we will look at how to create DHCP options. Finally, we will create the subnet and we'll modify the security rules and attach it to the subnet. And network steps are done, we can launch a Exadata database system. One of the note here is for deploying Exadata Cloud Service in OCI, you must have IAM policy which will allow you these kind of operations. One of the example could be allow group DBA admins to manage database family in tenancy. Let's move to the next slide. Some of the important points to consider. We recommend using one of the private IP address range which are specified in RFC 1918. The allowable OCI VCN size ranges from /16 to /30. You have to keep that in mind that VCN reserves the first two IP addresses and the last one in each subnet CIDR. Another important point to remember is VCN CIDRs must not overlap with your on-prem network or another VCN you are going to peer with. For ExaCS deployment, you need at least a VCN with two subnets, one for client and the other one for backup subnet. Backup subnets are going to use object storage access. VCN could be fully private and it needs a VCN resolver. You should be creating a custom VCN for ExaCS deployment, and you should choose different VCN IP range per region. As a best practice, you can keep VCN names short. You can include region to differentiate. You should keep the subnet name also short, and subnet name can have ADs in its name. You can additionally have regional subnets. Your host name is going to be in form of node name, then subnet, VCN, and oraclevcn.com. In order to create a VCN, you will have to sign into your Oracle Cloud Infrastructure console, and then you need to navigate to networking. Inside you will find virtual cloud networks, and you need to create a VCN. In this example, I have given a name as VCN_BAL. You need to select the virtual cloud network only. You need to specify the CIDR block. You are going to use the DNS host name in this VCN checkbox. For DNS level, automatically it will get it from the name you specify. So once you provide all these details and click on create virtual cloud network, you will see that is appearing in your console. Next step is to create a NAT gateway. This is optional and it's not needed for provisioning. Only when you have a use case for your ExaCS system to talk outside, you are going to create this. So the advantage of a NAT gateway is instances on private subnet can initiate connections to public internet. Connections initiated from the internet are blocked. Since we want our deployment to be on private subnet and don't want to expose database compute on public internet, we have an option to create a NAT gateway to provide access outside. So in order to create, you will go into networking tab and provide it a name and click on create. So it is going to create a NAT gateway, and that will be available in your console. As a note, you might want to have a NAT gateway configured. One of the use cases would be to upload diagnostic logs to Oracle support portal directly from ExaCS node in case you are raising a service request with Oracle. Third step is to create a service gateway, and this is a mandatory step and suggested by Oracle. A service gateway allows access to object storage and all of the services in Oracle Service Network. So later we are going to configure our backup route table so that Exadata backup can travel to object storage within Oracle Cloud Infrastructure Network Fabric without traversing through public internet. The another advantage of this one is even the data subnet within ExaCS deployment is going to use a service gateway. By using service gateway, it has the ability to download any patches. It can talk to object storage to get required patching images for operating system updates. Next, we need to create the routing table, and virtual cloud network use virtual route tables to send traffic out of the VCN. Each rule specifies a destination CIDR block and the target for any traffic that matches that CIDR. For Exadata deployment, we will create two routing tables, one for client traffic and the other one for backup traffic. In order to create, we need to select the VCN. Inside the VCN, you will see create route table. Once we go into create route table, we need to provide the name. You can give it any name. You can click on create route table. So you can create multiple route tables, as I said, and later you'll be able to attach the service gateway which you have already created within ExaCS in previous step. Or if you have created a NAT gateway, that can be attached as well. These are some of the screenshots from one of my environment. We will look at all these details once we will get into the demo. So I'm not going to spend any time as I have covered a demo talking about all the steps required to prepare the network as well as deploying the Exadata system. You will be creating security list, and security list controls the ingress and egress rules. They specify the type of traffic which are allowed in and out. So you configure your security list at the subnet level, which means all the instances in given subnet are subject to same set of rules. In order to create a security list, you will have to get inside your VCN. You will be creating individual security list, one for data subnet, the other one for backup subnet. In case you have other applications needs to be deployed, you can create additional subnets for them and additional security list as well. So one of the use case would be to have Bastion host, and for Bastion host you can define one separate security list because Bastion host is going to be hosted on a public subnet. These are again the screen captures from my environment. In terms of DHCP options, VCN uses DHCP option to automatically provide configuration information to instance when they boot up. When you create a VCN, it comes with a default set of DHCP options. It comes with initial values. We can change or we can keep it. So in this example, we are going to use default DHCP option for Exadata, and it is also recommended for ExaCS provisioning. It has internet as well as VCN resolver in terms of DNS type. So we'll keep the default DHCP option and we are not going to create any additional. Once you are done with previous steps, you can create the subnet, and subnet is a subdivision of VCN. Each subnet in a VCN exists in single availability domain and consists of contiguous range of IP addresses that do not overlap with other subnets in the cloud network. In this example, we will be creating 4 different subnets, one for data subnet for Exa, the other one for backup subnet of Exa, one additional for Bastion host, and the last one for applications. Additionally, you can select regional subnets, which is recommended over ADS specific subnets, and regional subnets allow you to create instance in availability domain within region, and that way it provides better high availability. We will follow the steps. You will be able to see that when we get into demo. In this example, I have created 4 subnets. Let's move to next one. In this slide, I am showing how we can edit a subnet once we have created, and we can attach a routing rule or routing table. as well as security list to them. In this case, I am associating it with default security list as well as IFS access, which is to provide access to a file service. We'll see in the demo the actual steps for doing all of this. In case you want to use backups, you will go ahead and create a storage bucket. You will have to provide a name to it, and this is also required since as of today console is not providing automated backup for Exa. We need to use APIs in order to configure the backups. Next step is to add the rules to security list. Just for understanding, we need to update your security list and add appropriate ingress and egress rules to allow traffic. In the console, when we get inside the VCN we created, under resources tab we have security list as an option. That page allows us to create a different security list. We recommend to create a different security list for your subnets, one for data, the other one for backups, and if you have applications you can have additional security rules for them. If you are using any specific services, better create separate security rules for them as well. Depending on the need, we will create the required ingress and egress rules inside the security list. I'm going to skip this slide. It shows in my default security list how many ingress rules I have, but we'll cover in more details a better way to create all of these network resources when we get into demo. So that was about creating network, and once the network steps are done, you are ready to launch an Exadata database system from OCI console. In the console, you need to open the navigation menu, and under databases, you will click on bare metal, VM and Exadata. You need to select your compartment, and then you have an option to click launch database system. In launch database system dialog box, it will ask several inputs which are listed here. In terms of shape type, you will be giving cluster name, the CPU core count, as well as the shape you have selected could be from X6 or X7 versions. Then in networking section, it will primarily look for virtual cloud network name as well as client subnet and backup subnet details. Then it comes database section, where you need to provide a name to database, which is going to be your starter database. Then you need to also specify PDB name if your database version is 12.102 and later. And by selecting the database workload type, either as OLTP or DSS, you would be able to launch the database system. One note here is you should be selecting database version as the highest available version in the OCI console, and that way it will make sure your grid version is going to be at the same level, and you will have compatibility of 11G till the latest version of grid. This screenshot shows how to launch an Exadata database system from OCI console. I will spend some time here. So in database system information, you have given a display name to your database. You have selected the availability domain. Then in shape type, we are selecting Exadata and the required shape. I'm going with Exadata Quarter Rack 2.92, which is X7 version of Exadata. It will automatically come with 2 nodes, and the database software edition cannot be changed as Exadata uses Enterprise Edition Extreme Performance. You need to provide the cluster name as well as CPU core count, and this will be based on your subscription. Select the license type, whether license included or BYOL. Once you are done with it, you need to also specify your SSH public keys that you are going to use later. Means you need to have the private keys for the public key you are providing in the console. Next section shows the storage allocation, and this is something based on your requirements you are going to check these boxes. If you want database backups on Exadata storage, you can check this one. Based on that, your disk group distribution of space is going to change. If you also want a sparse disk group, you can check that one. That situation, you will have 35% of storage space available for data and 50% for echo and 15% for a sparse disk group. A sparse disk group is for snapshots or a snap clone. It is based on copy on write technology. So Exadata provides a sparse clone functionality, and that is used for test, dev, and UAT kind of databases. Another option you can see here is time zone information, and inside time zone you have UTC as well as the selected regional base time, or you can also specify any other time zone if you want. Next comes database information, and we provide a database name. This is the starter database which is going to be created. You will have to select the database version. You should be selecting the highest version available if you want to get compatibility or database forms for all of the previous versions. You need to specify the PDB name, give an admin password, and then you need to select the database workload type, whether it's OLTP or decision support system. If you click show advanced options, it will show you the character set information. Once you have decided on all of these options, you can go ahead and launch the database system. In terms of network information, on the database provisioning page, it will ask you to select your VCN and the subnets for client subnet as well as backup subnets, a hostname prefix, and based on that you will be able to launch the database system. So once you click the launch database system, you will see Cloud Console showing up. There is a database provisioning going on, and in case of quarter rack configuration, it takes roughly 4 hours of time. So you'll have to wait for that to get completed. Once the database will get provisioned, you will get a notification saying that database system is ready to be used. This is how it looks like when database provisioning is going on. In this example, I have selected core count as 6. The disk redundancy is set to high. You cannot change the disk redundancy while provisioning. It is always going to have high redundancy. The port number is 1521. The cluster name is appearing over here, and all of the subnet information which we have provided. So these are all private subnets which I have selected during provisioning. Once the provisioning gets complete, you will see a scan DNS names available here, and you would be able to see the node information based on the host name prefix. There are 2 hosts which are available here, and their private IP addresses. It will also have floating IP address, that is nothing but virtual IP. So we have seen how a database can be provisioned. Now we'll talk about secure access via Bastion server. And since Exadata system is on private subnet, you need to connect it using Bastion host. The best practice is to create a configuration file for SSH on your client host to access the deployment of ExaCS on private subnet using proxy host. So Bastion host which we'll create is going to work as a proxy host, and this is one of the example. I have a configuration file which defines all of the hosts in my OCI cloud infrastructure. So the first host is Bastion host. It uses the user OPC, and the IP address is specified in that. I have also specified the identity file. This is the private key through which I can get into Bastion host. And for all other hosts which are on private subnet, Exadata nodes 0.3 as well as 0.2 here, they all use proxy command to connect to Oracle Cloud Infrastructure. For creating a Bastion host, it's a compute node. You will have a separate ingress and egress rules for that. It will need a public subnet. This diagram shows how I have defined my stateful rules. So it is from all the sources. I have enabled TCP protocol, and destination port is 22. So it is going to allow TCP traffic from on-prem systems to Oracle Cloud Infrastructure. And from there, since it is part of the same VCN, I can connect to other resources as well which are on private subnet. Once Exadata system is provisioned, we will be verifying the database as well as system information. So first time when you have to log in, you will be using OPC user, and OPC has sudo rights. So it can sudo to root, grid user as well as Oracle user. From root user, I have given a command dbus-cli, which is a command line interface, db home info. So it shows me dbus-cli version is 18.2310 and all the details about my database home, the location, the patch set level for which we have selected during provisioning, and the database name which we created. And this cloud tooling can be updated regularly. It is good practice to update it. The other command I have issued is dbus-cli database status, and I'm providing database name as an argument. So it shows all of the instances are running and their respective nodes, and also their Oracle home on the system. Another way to check out is you can log into your Exadata node. I have logged into 10.0.0.2, and then from OPC user I'm able to graph for machine types, and it shows me it's X72 elastic rack, high capacity 10 terabyte. So this information comes from database machine.xml. In order to get into grid, you will have to do a sudo to grid, and then you would be able to write queries and get details on all the fail groups or ASM disk properties. In order to get inside ASM, you can also issue a command asm-cmd, and through that one we would be able to query how many disk group we have. In my case, it's data as well as reco and sparse, and their respective size, the free MBs. At a file system level, if you issue df-h, you will see all of the homes which are got created. So ExaCS is one of the database system where we support multiple database homes. So it's different than DBus VMs as well as bare metals. In addition to these file systems, there is another mount point which is ACFS volume, and ACFS is ASM cluster file system. So if you need more space, you will have to create ASM cluster file system, and you would be able to mount it on the ExaCS compute node. This could be shared because the space in ACFS comes from a disk group, ASM disk group. You cannot attach the block volumes to Exadata systems, so for a staging kind of requirements, ASM cluster file system could be helpful. Now let's talk about ExaCS deployment, some important things to consider. In order to launch, as I said, quarter rack might take 4 hours, half rack can go for 6 hours, and a full rack can go 8 hours. For secure erase, it takes 6 hours for all of them. Termination could be done in minutes. Some of the best practices: passwords, you should not use system or Oracle as password. SSH keys, you should use one with no spaces in the comment field. Adjust the huge pages depending on database and memory requirement, and there are mouse nodes which are available to guide. By default, when database gets provisioned, it will be with huge pages already. In order to connect to database at application level, you can make sure the services are set properly. If you want to modify them, this is one of the example which is shown over here. Setting up Exadata system is not just through OCI console. You can use different methods like OCI command line interface or Terraform or SDKs. It supports functions like creation, termination, scaling up and down, create, delete, database homes. So there are API methods also to deal with the deployment of Exadata system. One of the example is OCI DB system launch, and you need to specify certain parameters, and this is documented under this reference link. If you want to do it through command line, you can take a look at it. Some of the sizing and consolidation best practice. So X7 was introduced some time back, and the pricing model was changed for it. So that allows you to scale all the way within the shape up to maximum allowable OCPUs, and you can bring it down to 0. So bringing it down to 0 will shut down the VM, and you won't be charged for the database OCPUs, but infrastructure component will be still charged. So there are two pricing component. One is for infrastructure, the other one is for database OCPUs. The console provides you a way to scale it up or down. The same thing can be also achieved through command line interface. So there are no CPU minimums, and this is different than X6 where 22 OCPU was minimum requirement. So you should not use less than 4 OCPUs per node, just as a best practice. So there are no impurity allowed. You cannot have one of the compute node as 4, the other one as 2. So it should be equal numbers. Size for storage capacity and IOPS. CPU can be scaled based on the demand. ExaCS shape change is not possible at the moment, so only method to adopt here is to use data guard for migration. So it is very important for you to keep that in mind. If a workload requires half rack, better go for it than doing this whole migration effort. In terms of consolidation on ExaCS, you should be using CPU count to distribute workload. For production workload, we recommend partitioning approach, means enabled core should be greater than sum of all the CPU count. In case of test development, you can take a over provisioning approach, and enabled cores can be 3 times sum of CPU count. So you can use resource manager for intra-DB workload, and you can also enable IORM for IO distribution. Let's talk about the demo flow. First thing, we will prepare the network. As part of that, we will create a VCN, and that will include a CIDR block of our choice. In this example, I am going to use 10.0.0.0/19. Only thing you have to keep in mind is the subnets will also require contiguous CIDR block, and it should be subset of VCN CIDR. While creating a VCN, we will use option virtual cloud network only. And the second step is going to be creating the service gateway. We'll give service gateway a name. I'm going to create all of my resources in one single compartment, and the service type will be all services in Oracle Service Network. The third thing is creating a routing table. We will create 2 routing tables, one for data subnet, the other one for backup subnet. It will be associated with routing rule, and this is going to use the service gateway, which we have already created earlier. So that will be the target type within the routing table. Next, we'll create a security list, and we will be creating 2 of them, one for data and the other one for backup subnet. When we'll create the subnets, we are going to attach this security list to those subnets. In addition to that, we'll create another default rule, which is going to be a copy of the rule which gets created with VCN creation. We'll create the subnets which are required for Exadata Cloud Service, and it is going to be 2 of them, and both subnets we are going to keep as regional and private in nature. This will also include the CIDR block, and we will provide a subset of the VCN CIDR here. In this demo, we will create 10.0.20/24 subnet, and the other subnet will create 10.0.3.0/24 subnet. It will be associated with security rules which we have already created earlier. For data, we have created a security list, as well as for backups, we have created another security list. So once this networking preparation is done, we will go ahead and provision Exadata Cloud Service. So as part of ExaCS deployment, it is going to ask information on database system. We'll also provide network related information. Then there will be a section on database information, and finally we will be able to launch the database system. Once the Exadata system is provisioned, we will log into the console, and I will show you what kind of operations you can perform using OCI console. So let's get into the demo now. So let's get into the demo. Here I have opened cloud.oracle.com, which provides me a way to log into my tenancy. So go to the sign in, And in account tab, you have to provide your identity domain. In my case, it's OCI OB enablement. Click on the next, and then it authenticates you to Oracle Cloud Infrastructure. Before we get started with ExaCS provisioning and networking preparation, I want to show you few of the basics. You need to have a compartment where you are going to create the resources. In my case, I have a compartment which is listed over here. You can have one or more compartment, and it is a design consideration. You might have decided what is going to be the name of compartment. So I will show you how to create a compartment and how to make sure you have required permission or privileges to create Exadata Cloud Service resource. So for getting those details, you can look at your identity tab here, go to the users, and make sure the user has required permission. In my case, I'm going to use my login ID, which is bal.sarma@oracle.com. I am part of this tenancy. Users are always a part of a group. So I will take a look at the groups here. There are several groups in my tenancy, and I'm part of administrators group. So depending on your configuration, you will be part of a group. Only thing what you have to take care of, you should have required policy which will allow you to do the deployment task. So if you look at, I have few policies here. One of these policies is database access, and I have the manage right. This keyword you can note here. So allow group administrator to manage database family in compartment Bal Sarma. So depending on your compartment and your username, you are going to create a policy which will allow you to do this kind of administration task. For creating compartment, you can always go to identity tab, navigate to compartments, and you can click on create compartment. You will have to provide a name, a description, you need to also select your parent compartment, and in my case, the identity domain OCI enablement is my parent compartment. You can have one or more compartment could be nested also. So select it appropriately. So without wasting time, we will get into the network preparation step for Exadata Cloud Service Provisioning. You need to navigate to Networking tab in Virtual Cloud Networks. In my case, I have few VCNs which are already created in my compartment, but I'm going to show you how to create the virtual cloud network, and that is the step 1 for preparing the network. So give it a name. I'm going to give it a name as ExaCS VCN prod. The second information it asks is in which compartment you are going to create this VCN, and I have selected Bal Sarma, which is my own compartment. You can select any of the compartments which you have already created for this provisioning. There are two options here. One is create virtual cloud network only, and the other one is create virtual cloud network plus related resources. So there are special requirements for ExaCS provisioning. So I'm going with advanced configuration by selecting create virtual cloud network only. When you select create virtual cloud network plus related resource, it automatically sets up a virtual cloud network with access to the internet. And you can also set up firewall rules and security lists to control the ingress and egress traffic. All related resources will be created in same compartment as the VCN. So I don't want this. This is a good option, especially if you are new to Oracle Cloud Infrastructure and you want to quickly deploy a resource such as compute or databases. Another important point here is you need to provide a CIDR block. You might have already decided which CIDR block you are going to use. So I will provide a CIDR block of /19. Only thing you have to take care here is like it should not overlap with other VCNs. Another consideration is, especially if you are configuring it with your on-prem system and you have a VPN or fast connectivity, you will decide this carefully. There should not be a conflicting virtual cloud network, which might cause issues later. I will keep this DNS resolution checked. I will be using this DNS hostname in the VCN. What it does, it creates a DNS label as well as a DNS domain name. So in my case, it has showing the VCN name .oraclevcn.com. So this is the only information which is required for creating a virtual cloud network. Go ahead and create the virtual cloud network. So we'll be creating all of these resources which are needed for provisioning. The second task I'm going to do is, after VCN creation, I will go ahead and create a service gateway, because the VCN needs one or more gateways in order to communicate, and service gateway has the ability to communicate with all of the Oracle Cloud Infrastructure region resources. So I'm on service gateway page here. Right now I have no service gateway. I will go ahead and create one. You need to provide a name to your service gateway, and I will give it ExaCS Network. It is always a good idea to give a few keywords so that you can identify what kind of resources it is. So since this is a networking related resource, I have given NW just to differentiate. Again, it is going to ask which compartment you want to create your service gateway. I'm going with the same default compartment. I will select the required services. So there are two options which you will see within service gateway creation. One is OCI object storage. The other one is OCI IAD service in Oracle Service Network. So this might change depending on the region. I am in Ashburn region, which you notice from here. So it's showing me OCI IAD object storage. I want this service gateway to be used not only for object storage access for backups, but any other resources which I might be interested within Oracle Cloud Infrastructure. So I will select all IAD service in Oracle Service Network. After providing these inputs, click on Create Service Gateway. It will provide a confirmation that your service gateway has been created. And another note it says is, make sure to add a routing rule and security list rule for any subnet that needs to use this service gateway. And gateway must first be available before you go and try creating these subnets. So that's why as a second step, I created this service gateway here. I click on close. Service gateway which we created will appear in the dashboard. So it shows it's in available state and it supports all services in Oracle Service Network. So we will see how we will add a routing table. So the VCN we have created is ExaCS VCN prod. When we created this VCN, there were a few components which got created. One was DHCP options, and this is the default DHCP options for the VCN. I am going to use the same DHCP option for my ExaCS provisioning. It provides DNS type as internet and VCN resolver. It's in available state. So this is one of the default resource which gets created when you create a virtual cloud network. The other component you will notice after creation of this VCN, there is a security list, and it is default security list for my VCN. We can either use this default security list, or you can create a copy of this with the same rules which are already specified within this security list. And these are some of the mandatory security rules which are needed for ExaCS to operate in terms of connectivity and internal communication. So I don't want to use the default security list. In that case, I will create another security list and have these rules added in that new list. And apart from that, I will be creating additional security list, which I will show you when we go to security list creations. The next thing we are going to do is we will create a routing table. And right now I have a default route table which is available, but there are no security list and routing rules associated to this routing table. So for creating routing tables, we will go in a route tables tab, and there is an option to create a routing table. Give it a name. I'm going to create two routing tables, one for my client subnet, the other one for my backup subnet. The another input it will accept again as compartment, which by default is selected to my compartment, and it shows like there are no routing rules associated here. We will modify this routing table once we will have security rule created. So just go ahead and create this routing table. The another routing table we will create is for backup subnet. I have given it a name. Again, selected the compartment and click on create route table. So now my routing table list shows three of them. One was the default one, and the other two which I created, one for backup and the other one for data subnet. The next thing is to create the security list. So click on create security list, give it a name. I've given it a name ExaCS_sec_default. Again, I have selected the compartment, and now I'm going to add the ingress rules which is needed for this one. So in source CIDR, you will select source as 0.0.0.0/0, and the protocol is TCP, and the destination port should be 22, which will allow a SSH session from within the Oracle Cloud Infrastructure Services. And I have kept source port range as all here. So once the ingress rule first one is created, go ahead and create additional ingress rules, and we will provide a source CIDR of 0/0, and the protocol is going to be ICMP, and type you can select 3, and you can leave the code which is an optional. Add additional rule for the same. We want to enable ICMP with 2 types, so now I will provide type as 4 and code all. So this is my ingress rule 3, and another ingress rule I'm going to create is which will have source CIDR as the VCN CIDR. And this will be again for ICMP traffic, and type equals to 3. So let's go through it. In the default rule which we are creating, I have just replicated it. The first one with source CIDR 0.0.0.0/0, and it's for destination port 22. Again, I created 2 ICMP rules as ingress rules, and it's for type 3 and 4, and another ingress rule for the source CIDR as of VCN's CIDR range. And these security lists contains several basic rules which are necessary for database system, such as ingress SSH, access to the database system, and general egress from the database system. So go ahead and click on create security list now. So now I'm provided with my default security list. I'm not going to use this default security list for ExaCS VCN prod, as any changes I will be doing on this security list will impact my ExaCS production. So now we will create two additional security lists, one for client subnet and the other one for backup subnet. And this security list will have multiple rules which I am going to show you now. So click on create security list, give it a name. I've given it a name ExaCS sec data. Again, the same compartment, and you need to specify rules for ingress and egress. So the first rule I'm going to add here is it's a ingress rule, and this is for allowing the ONS, which is Oracle Notification Service, and FAN traffic from within the client subnet. FAN is for fast application notification. So by default, all the rules are stateful unless we select it to be stateless. And this particular rule for which we are going to create has to be stateful. So we'll not check this one. In the source CIDR, leave it as CIDR, provide the client CIDR here. Next, we are going to create two more security lists, which will be used, one for client subnet and the other one will be for backup subnet. So go to create security list and give it a name. We are in the same compartment and we will specify ingress rules. So I have not created my client subnet and backup subnet yet, but I have already decided on which CIDR block I am going to use for them. So let's put this as, I'm assuming here that for my client subnet, I'm going to use this CIDR block 10.0.20/24. I have provided IP protocol as TCP. The source range is going to be all and destination range will be 6200, which is needed for ONS and FAN events. So this is a stateful rule. I will create another stateful rule, and this is for allowing the SQL star net traffic from within the client subnet. So again, source type is going to be CIDR, and here I will provide the same CIDR range which I am going to use for my client subnet, and IP protocol is going to be TCP, source port range is going to be all, and destination port range is 1521. So this will provide me SQL star net traffic from within the client subnet. After creating these two ingress rules, I will create additional 4 rules, 2 for ingress and 2 for egress traffic. And the purpose of that is to allow TCP and ICMP traffic inside the client subnet, and it will enable the node to communicate with each other. And these are the required steps for ExaCS provisioning. So let's go ahead and create additional ingress rule here. So I will go with CIDR, and source CIDR is going to be the IP address range, which I am going to create for client subnet. Port is going to be TCP, and source port range all and destination port range all. So this will allow TCP traffic for all of the ports within this client subnet. The another rule is going to be for allowing all the ICMP traffic. I will leave it as all and all. So this completes the ingress rule section, and now we'll create 2 egress rules. So in this example, we are creating the egress rule, and you need to provide your client subnet CIDR and it is going to be TCP source port all and destination port all, and another egress will have ICMP traffic. So take a look at which security rules I have created within this security list. So I have created an ingress rule which allows TCP traffic 6200, and that is for our FAN and Oracle notification service events. The other one is to allow port 1522. The third one is for allowing TCP traffic for all of the port ingress rules for client subnet. Then I have allowed ICMP traffic within my client subnet and 2 of egress traffic rules here. So this completes the security list creation for my data subnet. So click on create security list, and security data is created and available inside my security list rules. Now we are going to create a custom security list for backup subnet. Click on create security list, give it a name. We have the same compartment here, and then you need to add a egress rule which will allow access to object storage. And here you can select service type, destination type as service, and selected service could be ID object storage, and IP protocol TCP, source port range all, and destination port range 443. So this provide access to object storage through the service gateway, and it is one of the redundant since we are already using a service gateway which will by default give access to all of the Oracle services within cloud infrastructure, but still we'll go ahead and add this rule here. So now this screen confirms my security list are all created. So let's go ahead and add the routing rules. You need to select the target type, which is going to be service gateway in my case, and select object storage from here, and compartment is selected. And remember, we have already created a service gateway before, so select that particular service gateway which we have created earlier, and then click on add route rules. Now we'll also modify the client subnets routing rule, and this is also going to use target type as service gateway. Select all services in Oracle Service Network, because that way it will ensure you are able to get the patches also from YAM repository later on. So this completes the routing table setup. Now we are going to proceed with the subnets, and we will be creating 2 subnets, one for data and the other one for backup. Click on create subnet, give it a name, Oracle recommends to use regional subnets, which is recommended. You can still go ahead and create AD specific subnets, and that will also work, but recommended approach is to create regional, and that way instances in the subnet can be created in any availability domain in the region, and it is useful for high availability. So provide the CIDR block, which I have already decided earlier. The CIDR block I'm going to use is 10.0.20/24, and you need to select the routing table, and we created a routing table for ExaCS data subnet. The subnet access, I'm going to select private subnet because that is the recommended approach. I will keep this option DNS resolution as checked, which will provide DNS label, domain name, both of these are already populated. Next, we will select the DHCP options, and as I said in the beginning, I will be using default DHCP option which got created as part of VCN creation. The next, it expects security list which are going to be attached, and you can select a security list which we have already created. So for data subnet, we created this one, security data, and I also created a copy of default security rules, so I will add that as well. So let's review what information we have given here. We have given it a name, we created a regional subnet, we provided the CIDR block, we attach it with the routing table which we have already created earlier. Subnet access is going to be private subnet, and you need to select the DHCP options which we have given default DHCP option, and then the security list which we created. The security list which we created, one custom security list and the other one default security list. So with this, you can click on create subnet, and I see that the subnet is available with the CIDR block which I have provided here, and it's a regional subnet. So next, go ahead and create the backup subnet. So I have given it a name, ExaCS Subnet Backup. Again, subnet type I'm selecting regional. I need to provide the CIDR block which I have already decided, and it's going to be 3.0/24. So this CIDR block gives me 256 IP addresses, which is more than enough for ExaCS provisioning. A routing table we have already created. This subnet is also going to be a private subnet. In DHCP options, I will select the default DHCP option, and then I'm going to select the security list which we created earlier for backup, and it will also use the default for egress rules. So this completes my subnet creation for backups. So go ahead and click on create subnet. So both of the subnets are ready here and they look as available. Now I'm going to show you how you will start provisioning the database system once you have all of these steps ready. You will click on launch database system. So you will specify a name. You need to select the availability domain. For Exadata system, you'll be selecting Exadata. You need to specify the shape. So this is what I was discussing. You have an option to select either these three options or this one. 2 represents, all these 2 dot represents the X7 versions of Exadata Cloud Service, and all ones are for X6 versions. You will have to look at what service you have subscribed to, and based on that you will be selecting. Here total node count is by default populated to 2. If you go with 2.184 means half rack, it is going to be 4 compute nodes. So you need to specify a cluster name, provide a name to it, how many CPU cores for your compute nodes, so 4 or 6. Based on your subscription, you are going to provide that. You will be going with license included or BYOL depending on your subscription. Again, you need to specify the SSH public key here. I have selected a key randomly just to show you. Once you provide these details, you have a storage allocation, and as I said, if you don't go with these 2 options, the distribution is 80% data and 20% reco. If you want a local backup to be done, then it reduces, so 40% data and 60% reco as distribution. But if you again want a sparse disk group, that's 15% is getting reserved here for your sparse disk group use cases. The advantage of a sparse disk group, but it is used for creating databases from a test master database. Test master is a read-only copy of your production database, and that is used to create additional databases for development, UAT, and test purposes. So all the sparse sparse disk group databases are going to be thin provision. It uses copy and write. the size of the database when they are created from your test master is going to be in few MBs, and or it will look like a full-fledged database for users, but all the read operation goes to test master and all the writes are performed locally. If you want to or intend to use this feature for your test dev and non-prod use cases, you have to select it during deployment time. If you miss out, we are not providing any other way to enable this sparse disk group functionality later within the environment. Once you have done with this decision, like disk redundancy, you cannot change it. It is going to be always high. You have an option to change your time zone. So UTC is by default. You can select any other time zone from this browser. Then you need to select the networking information. The VCN you have created already. Think of, I have a VCN client subnet. I have private data. For backup subnets, I created a private backup, a hostname prefix test, and then you are done with the networking information. Only information left is database information, so we will go ahead and give it a name. If you click on this display all available versions, it will show you different versions available. So right now in my tenancy I can see 11 to 04 till 18. If you want back support all of the latest 18C grid, you should be going with this. It is not going to force you to have all of your databases on 18C. You have an option. You can always create a database later of either 11G or 12C, 12.102 or 12.2 or 18C if you go ahead with the latest version upgrade. Give it a name. By default, the starter database which gets created on OCI ExaCS is always going to be a multi-tenant container database. You need to provide the PDB name, give a strong password here, and what kind of database workload you want. Another options are character sets which can be changed from here, and then at the end you have an option to launch the database system. So once you do that, your database will appear in your under bare metal VM and Exadata tag under databases, and once the database is there, you can always create another databases. I want to create one more database. It asks from the console, you can provide database name. You need to select the version. So since my grid is at level 12.2, I do not see 18C as a version. Select 11.204, just give a password. And you would be able to complete creating this database. So this is the only input. Since Oracle homes are already there, any version can be created. Keep that in mind, like you have one single VM on each of the compute node, and these will be in the different database forms. So 11G database will be under 11G database form we saw earlier, and same with any other version. So this is how you create, and it takes some time to appear here under this console. So this is one of the way you go ahead and create the database. We have APIs method also to create any database on Exadata Cloud Service. Few of the things if you note here is, unlike the other DBAS services, you do not see backups and patches. So these backups and patches are done through APIs as of now. Backup is one-time configuration using backup_API, which we'll see in the next module. And patches are also supported through ExaDBC multis, which might change in the future. We can have automatic backup and patching operations here. You can always scale up and down from this console. I can do a scale to 4. It is not going to impact the availability of your database. You can also update. While updating, the color will change, indicating that there is a change happening on the system. You can always add more SSH keys to it. You can update the IORM settings of the database system. Just to summarize, we described various features of Exadata Cloud Service. We understood Exadata as well as its core architecture. We also looked at deployment best practices. We described the aspects of service management in Exadata Cloud Service. We provisioned the Exadata Cloud Service using console. We looked at architectural best practices for database workload, as well as consolidation best practices and sizing. I believe this session was useful and thanks for spending time with me. For more information, you can log into cloud.oracle.com/IaaS and also subscribe to Oracle Cloud Infrastructure YouTube channel. Thank you.